Thank you, everybody, for joining. Everybody, welcome to this webinar. We're very excited to have you join us today for the webinar on Unlocking the Future of Utility Mapping, AI-Driven Solutions for Real-Time Remote Access to Reliable Data, featuring Raz Ezra, Jim Anspach, and we actually have a special guest today, too, John Campbell. But before I get started here, I just wanted to do a couple housekeeping items. First and foremost, hello, I'm Chris Garafola. I'm the Senior Content Manager here at 4M, and this webinar will be recorded. So we will be sending out the on-demand webinar sometime early next week. And if you guys have any questions during the webinar, we want this to be interactive. Please feel free to drop them in the chat below or in the Q&A. And we'll address those at the end of the webinar. We'll try to leave some time. And if we don't get to all of your questions, don't worry about that because we will follow up with you guys individually afterwards. So without further ado, I'd love to introduce you guys to Raz Ezra. Do you want to kick it off?
Yeah, for sure. Thank you so much, Chris. And thank you for all the different people that joined us today. My name is Raz Ezra, and I'm here with 4M Analytics based in Austin, Texas. Coming from Israel, so I moved with my family, wife, and two crazy boys about over a year ago from Israel. I'm one of the guys that co-established the company, which happened about 4 years ago. Coming from the military as a former officer from the Combat Engineering Corps in the Israeli military, I used to deal with landmine clearance and explosives for over 10 years. This is what brought me here to this opportunity to establish 4M together with the founders and meet with all the amazing people here in the room. So with that, I will transition that to Jim.
Sure. Jim Anspach. I am currently the chair of the Utility Engineering and Surveying Certification Board, which is part of ASCE and the Civil Engineering Certification, Inc. Organization. I was chair of ASCE 3822 and 02, but John Campbell has told me it's time for me to go, so he's going to be chair of 3827. So anyway, that's my background. I'm a geophysicist by education. Currently, I'm a professor of civil engineering, construction engineering, and environmental engineering at Iowa State University.
So maybe piggybacking on that, so you mentioned our friend John Campbell, which is a funny story. So we don't see here the name or the face of John. So it happens to be that I just had lunch together with our dear friend John, and we were like, okay, we have this webinar together with Jim. How about you join us spontaneously? And he said yes. So I'm going to pass it over to John to introduce himself right now.
Well, thank you very much, Raz. I am John Campbell. I'm with T2 Utility Engineers based out of Austin, Texas, or Round Rock, Texas, here in the central part of Texas. I spent 27 years with the Texas Department of Transportation, where I was their statewide utility engineer for a spell, and finished my last 15 years with TxDOT as the director of the right-of-way division. I've been involved in this pursuit of getting good data on existing utilities since the day I met Jim Anspach back in the mid-90s. And so I think we both are a little surprised to have seen the things that we couldn't have imagined happening while we're still actively working in this realm. So just happy to be here, sharing the passion that I have for this practice.
Yeah, thank you very much, so Jim and John. Before we dive into the topic, I'd like to at least introduce 4M Analytics at a high level that is hosting this panel or webinar discussion that we're having today, and then we'll transition into the topics that we'll talk about today. So for the people who don't know 4M yet, 4M Analytics, you can kind of think about 4M as the Google Maps of utilities. In terms of above and underground utilities, the 4M company or product is basically proactively mapping the whole country of the United States in terms of above and underground utilities. We intend to provide a reliable and comprehensive utility data set or repository that can be accessed very easily through a web environment. So a user can log in, draw an area, and instantly can get access to data sets that were created by big data and analytics combined with AI mapping proprietary technology that we developed internally with 4M. The company is based in Israel, as I mentioned, established about 4 years ago. And we have also several people, about 20, 25 employees spread out over the country in the United States. So this is a bit about 4M. And what I like to do right now is I'd like to share my screen again and to kind of talk a bit about what we're going to do today. So I hope everyone can see my screen. Chris, if you can just validate that.
Yep, looks good.
And apologies again to John for not showing the face, but again, this was, from now to now. So we're going to talk about today about the hidden value or the opportunities that can be unlocked of what we have under the ground in terms of utilities and civil, how that aligns with the civil engineering domain, etc. We'll combine also the AI portion or the technology side that is driven by different types of technologies and companies that are trying to innovate and disrupt in the good matter, of course, this industry that we have here. So this is what we're going to talk about today. And it is going to be like an open agenda. We're going to have some questions that we're going to ask here to ourselves. People can feel free, by the way, to comment and ask questions in the chat box. So Chris, if someone asks any questions on the chat box, feel free to interrupt and ask us these questions. Yet we will also have some time for questions and answers at the end of the conversation, as well as we will save maybe a few minutes to talk a bit about 4M and the product that we are bringing and how this aligns with the conversation that we will talk about. So I hope I set up the stage good enough, and then we'll start with the very first question that I like to ask Jim, if that's okay. So what is utility data? Jim, how is it also important for any construction projects that people are dealing with here in the United States?
Well, let's ask a different question first, and that is, who uses utility data? And there's a lot of different entities that use utility data and find, obviously, if they use it, they find value in it in some manner. So utility owners are a logical choice to use the data. They generate it, they use it for their purposes. But contractors and land and right-of-way owners, project owners, designers, planners, the U.S. government, whether it is for security purposes or resource planning or budgeting and appropriations, they've got a role. Rate commissions use that data to figure out what is a fair and reasonable rate of return. What should we charge the rate consumer for this service? And even the individual citizen might use that data. Now, some of those users of data fall in more than one category, and there are probably quite a few users that I haven't mentioned yet, but maybe that would be a question to throw back to John and Raz.
John.
Well, I've been in the business of being a producer of utility data. And so a lot of my clients are the types of people that use utility data. And, those are going to be people that are looking to put an infrastructure project in place. And they want to make sure that when they do, they don't confront all the mystery of the unknown that lies below. So pretty much just about anybody that wants to dig safely is going to be a potential user of utility data.
So the following question that I would ask here, so when do we need utility data?
We need as much as we can get of it as early as we can in the process of developing our projects.
Okay, so utility data, as far as I can see, it can be utilized or acquired or collected throughout, obviously, the entire construction project lifecycle, from pursuit or early planning phases up to before putting a shovel into the ground, and even during maintenance, right? Now, the question would be, okay, where is the ideal phase to collect data? And I want to share with you my opinion. The answer is obvious, right? We want to get reliable data early as possible, much before we put a shovel into the ground, much before we even plan the project, to plan the project on reliable data sets. Now, in my opinion, when we're talking about early project phases, what are the solutions that we have? It kind of brings up the next question that I have in my slide deck here, is what is the technology that is available and where it can be utilized throughout the project lifecycle? As far as I see this, and I'd be happy also to get your opinion about that, Jim and John. So at the early phases of construction project lifecycle, we have available data that is shared, to the public, what is called like public records that can be utilized whenever, pretty easy to access. So this is the first thing, or the first methodology. The second methodology is field investigation, send people to the field. Now, so we have those two different methodologies, yet we have a conflict between each one of them, because early on in the project lifecycle, we would like to send people to the field because it provides the highest degree of confidence and accuracy. Yet not all the time we have the budget, we have the time to send people to the field because it's costly, it takes time. And we only want to know the conceptual aspect of the corridor. Yet, so if you go back to the first solution, rely on public records, the problem with here will be that the data is inaccurate, most likely untrustable, not up to date. So, but it does make sense to use that early on because we can easily access the data. Right. So I'm happy to hear your opinion about that.
Well, I think the key word is reliable data. And the reliability of the data, of course, has everything to do with the very dynamic environment that we install in construction projects. It's always changing. So reliable data, or the reliability of the data, is really the focus of our efforts at gathering that information, but more importantly, qualifying that information as being reliable for our purposes. I'm sure Jim has an idea.
Well, I would say the answer to the question of when do we need data is we need it before we are making a decision that has some amount of risk baked into that decision. And then, so that's when we need it, which means we need basically all the time. Now, how much do we need and how reliable do we need it? It depends upon that risk management decision. What are we using the data for, and what are the consequences of using incorrect versus correct data in that risk-based decision? And there's a broad spectrum of available reliability of data based upon those risk decisions. So it's not a clean-cut answer to the question. I think you have to shade all of that with, why do I need the information? What's the return on investment of that information? How reliable does it need to be for this specific task? And then you go get that information that you need and color your decision based upon the reliability of that and the consequences of having data that may not be reliable.
So, Jim, I think you brought up something very interesting that John and I just talked over lunch a few moments ago. So when we have a corridor of, let's say, 300 feet wide, do we really need a very high accuracy for the whole corridor of the alignment of the project? Do we really need that for the whole corridor, or do we need this very high accuracy on the areas or the conflict zones or points that we expect to encounter utilities while digging or putting a shovel into the ground?
Well, that's an interesting question, and I think we have multiple unclear answers for that. It depends upon what you're doing within that corridor. And we've always known, in fact, that's what ASCE 3802 and the concept of subsurface utility engineering, it all came about from that very question is, okay, we've got some project limits. We're going to be doing something in here. We don't know what it is we're going to be doing yet. what do we need to do to figure out the best thing to do within those project limits? And our answer back then, and our answer still, is use all appropriate means to figure out where utilities are. And at points where you need really good data, you might have to dig it up and look at it, a test hole, a quality level A, whatever you want to do, or call that. And in between, you've got either, records or professional judgment or common sense or geophysics to give you an idea of what's there. So I think the answer to your question is, yeah, we do need reliable data everywhere, unless we already know that the project limits are not going to create something within it that would be in conflict. But if we don't know what's there, and we don't know what yet we're building, or how we're moving it within those project limits, or why we set the project limits the way we did, I don't think we can answer that question.
So I think there are two different terms that we can discuss: accuracy and reliability or confidence, right? What do you say?
Yes, certainty and uncertainty. That's what I would say, and each of those may have some indication of accuracy associated with it.
John, what do you think?
Yeah, I think the same, and I would add to the certainty, uncertainty, the known and the unknown. So most of the answers, and Jim and I will be taking our show on the road next week to teach the utility investigation school. And, most of the answers that are to the questions that our students ask start with it depends answer. And it does depend, because every situation that we encounter requires a different set of information, a different level of accuracy, depending upon what it is that you're attempting to do and where those real conflicts are.
So I look at it very similar to, you take out some binoculars and you're looking for something in the distance, and you get those binoculars and you're looking, and it's kind of fuzzy at first, and you've got a dial on there that you can gradually tune that in to correlate to your eyes, the atmosphere, how far you're looking, and the size of the object in the distance. All of those factors combined. And that's very similar to what we would want to do within some sort of project limit, is say, how refined do I need my data at this point in time? And it may just be, hey, there's a hill over there. That's all I need to know. But if I need to know how many pine trees are on that hill, I'm going to have to really zoom in on that and be a lot more careful, and maybe even use different techniques. So when we're looking for how accurate or how comprehensive or how reliable does the information need to be within project limits, I think we really have to say, well, what decision are we making based upon this snapshot in time that I'm looking at right now?
So, Jim, I want to talk a bit about the challenges around getting a hold of utility data. And I want to share with you a story, a personal story that I had even before Forum Analytics evolved or even started. So going back to my maybe 10 years ago or something like that, when I used to clear landmines as a project manager, one of the processes, the preliminary processes, is doing the exact same thing. Having a record research, looking into the history, understanding and stacking up a lot of different images and records, understanding where are the classified hazardous areas, understanding what are the challenges or the explosive hazardous that you are going to encounter, and then plan the project accordingly while sending sensors using drones, GPRs, magnetic sensors, etc., to scan the area, and then eventually dig it while excavating with excavators and crushing the landmines. More or less similar, by the way, to the soup process, if you kind of think about that for a second. However, one of my very first projects about 10-ish years ago, so we dig the trench inside a minefield and we strike the water line. from like a minute after, we had like a swimming pool inside my minefield, which is kind of funny. And we weren't reliable to that, by the way. But however, we called the water company, and after a couple hours, this guy from the water company comes over and he tells me, "Hey Raz, let me mark this line so you won't strike it again." And I was like, "Okay, but where's your equipment?" Because we only had like a backpack. And he pulled 2 sticks from his backpack. He went like this and he marked it and he said, "Okay, there you go, don't hit it again." And I was like, "Man, this is very easy." So I don't think now, after 10 years after, I don't think it's really easy right now. And rolling back to my next question that I'm very curious to open up here is, so what are the challenges with getting our hands on reliable utility data?
Sure. So let me also tell a story. I started my career looking for gas and water lines and underground tanks and unexploded ordnance. But for the piping networks, we were looking to figure out how to stop them from corroding. So cathodic protection issues, where the leaks, and all of that. And so doing these inspections, it became very clear to me early on that even the utility owners' records are sometimes suspect. They had, in some cases, very good, accurate records, easy to find. And in other cases, they had no records, couldn't find them no matter what. They didn't exist anymore because some fool like me spilled coffee on them and they were paper, and they became obliterated. And we have those same issues today. Nothing has really changed. Utility owners will, up until recently, had to spend a lot of money trying to figure out, how am I going to position these utilities on my records so that I can find them again. And there's lots of challenges to that. But technology has helped us quite a bit in that. And it's as cheap and inexpensive and accurate now to do that function as it is to brew a cup of coffee almost at this point. Maybe it's even easier than brewing a cup of coffee in some cases. So I believe that the technology is creating the ability for us to do a much better job of collecting data that we didn't used to have, either collecting it ourselves for our own use or for any stakeholder's use, but also checking the reliability, the accuracy, the comprehensiveness of that data with advanced geophysics and Bluetooth and advances in software for multi-channel GPR and data mining techniques. All of that technology is making getting records and preparing records for future use a lot easier. But it still doesn't solve the problem of utility owners not wanting their records to fall in the wrong hands, or not having the staff to understand why it's important for somebody to get their hands on those records, or the ability to clip out a little section of the record so there's no network information and give that to a user who might need it. So there are still all of those challenges in getting good records from utility owners. Now, there are new technological solutions that help us bypass the current utility owner request that are showing promise. And what we're talking about here today with some data mining applications fall right into that category.
So Jim, I want to elaborate on that and ask a following question. So you mentioned a very important word, I think, that is reliability. In terms of the utility records, so I'm not an expert, unfortunately. I just got into this business maybe 4 years ago, to the civil engineering world when we established the company. But I have here two amazing experts, which are John and Jim. As an outsider, I see a lot of times dealing with records that we have a lot of different conflicts between records. so we can see maybe a couple, maybe even 5, maybe 10 different sources of records that will tell us a different thing about a very specific client. How are we able to deal with those situations, with those duplicates and with those conflicts among the sources?
Yeah, so reliability is a word that's thrown around a lot that depends upon the purpose. If you are planning, do I need more capacity down this street because we're adding 5 new houses, the answer of reliability might be, do I know the size and condition of my existing pipe? The location really doesn't matter that much. It's somewhere in the street. The location reliability isn't a factor in that decision at that time. So using the term reliable or reliability, I think it can be really misleading because it depends upon what the purpose you're using that data for. Maybe that didn't answer your question directly, but I have trouble with that word reliability. I use it myself, and perhaps I'm a little bit cognizant of, oh gee, maybe that's not the best term in this particular case. And I really want to hearken back to certainty and uncertainty, because if you are certain about something, it is reliable for any and all purposes, maybe. If you're uncertain about it, maybe some aspects of it would be reliable for your purpose and some aspects are not. So I think that term certainty or uncertainty is a much better term to use when we're discussing utility data.
John, any thoughts?
Well, the one thought that occurred to me when we were talking about what are the challenges in gathering that record information is time. It's a very labor-intensive, very time-consuming process in the traditional means with which we've carried out records research. And then you've got the fourth dimension of the passage of time that enters into the reliability of those records, because the subsurface environment, although we don't see it and it doesn't register with us every day, it's an extremely dynamic environment that is changing all the time. So you combine that with the labor intensity of gathering that information, the fact that it's changing in real time makes it very, very difficult to always feel that 100% certain that you know where the things that are going to impact your project are. That's my thought.
Let's think about it this way. When we look at where can we get utility information, whether it's reliable or not, where do we get it so we can start to make the determination, hey, that's pretty uncertain, or that's more certain, or here are 5 different records of the same thing. And as you say, I can take little bits and pieces of information of all 5 of those and make some sort of professional judgment or analysis saying, well, this is what I think is going on with that particular utility structure. And what we've always said in the ASCE 3802 and 3822 is, collect applicable and available utility records. And we try to get the as-built or record drawings or as designed record drawings or previous plans or conduit maps or cable records or distribution maps or field notes, one-call marks, all of these sources of information. And guess what? There's nowhere you can go to get all of those sources of information in one request. Normally, we call the one-call center and they send a message out to utility owners, and the utility owners give us what they feel like giving us, if anything at all, because sometimes they're not required to give us records in the jurisdiction. So the problem has always been, as John alluded to, how much time and how much cost does it really take to do a thorough deep dive into what existing information is already out there that can be used without going into the field, which we know is going to be another time-consuming and cost-extensive effort. And that's really what some of these new technologies like the cloud and data pools and the ability to pull information off of PDFs and photographs and satellite images, all of that in one place to get an idea of what's out there and start to make those judgments as to how certain is it, how reliable is that data.
So Jim, in the big data era, how do we conflate all this type of data? Or let me ask a different question, or just a second, I want to share my screen here. So let's take a step back. What is conflation? And I think you like this question.
Yeah, conflation, we throw that word around a lot. The first time I heard the word had nothing to do with maps or anything else. But the first time I heard it in response to data sets for GIS systems, essentially, was back with a firm called Sentinel USA. A friend of mine, Dan Colby, put together, and he was saying, yes, we conflate these data sets. We're taking land ownership and putting it over top of an image of the land, and we're taking these data sets and adding them on top of each other so that we can, with one view, kind of get an idea of different sources of information that might be valuable if they were combined. And that's really what conflation is. But when we talk about conflation, a lot of people don't understand that conflation is really that stacking of data, but you can't just stack the data. You have to analyze it. You have to say, is this a duplicate record or is this an additional record? And that is one of the most difficult jobs for somebody putting an underground utility map together. Is I've got 15 different sources of information. How many are duplicate and how many are additional? And there's a lot of intelligence that goes into trying to figure out that question. And then there's a lot of risk management in how you answer that question. If you're not sure, do you show 3 lines? If you are sure, obviously you could show just one, but where do you show it if you've got 14 different possibilities? So this idea of conflation by itself is the starting process of saying, let's pull together all of these data sets that we have available and start the process of analyzing them to see if they are duplicate information or non-duplicate information, and how do we rectify disparities in that information. So that conflation engine is an important first step, but it's not the end result. And unfortunately, I think a lot of our GIS managers throw data together, they conflate data and say, I'm done. This is what we've got out there. I've taken all the data sets. I've got the property lines. I've got the owners. I've got fire hazards. I've got the direction that the sun's coming. I've got the streets named, all of that in one data set. But by itself, it needs a little bit more action to produce the results that a particular person might need to use that data with.
So I think you're kind of saying, Jim, that the conflation process is basically to synthesize, and let me stop sharing my screen here, to synthesize all the data available to solve the duplicates, to correct the deviations, to verify it. And this should be like the opening process or the baseline level of data we need to have early as possible on the life cycle of the project, yet as much as this data set can be robust, comprehensive, certainty, or high degree of confidence, or whatever we like to call that, yet we will still need to have a professional engineer that really knows, have experience, and maybe even involve also field investigation with people like John Campbell that is sitting right next to me with T2 utility engineers. So we will still need to have an entity that will need to verify the data with field investigation while having the professional hat on the head.
Well, yes, I believe that. I also believe that if you look at any large data set coming from different sources, it's probably going to be a bell-shaped curve as far as its viability or its certainty. And some of that bell-shaped curve at the end, we know it's garbage. We have enough information in our data set to say, you know, I'm not going to pay any attention to that stuff. Those are outliers that make absolutely no sense. And I don't even need to be probably a professional engineer to make that decision. We could probably do that with some algorithms or artificial intelligence machinations to say, you know, let's cut that part out and let's pay more attention to the top of the bell-shaped curve and the good part and see how that all flows together. And yes, at some point, I think you do need an entity experienced in what makes sense given what I'm doing and what am I doing to do that. And in our society here in the US, we've determined that that's the civil engineer for the most part.
Jim, I love the way you explained that. I want to share with the audience here and also with you the way we describe, we at 4M, the way we describe the conflation process and how this can be potentially aligned with the processes or the best practices within the industry. So Jim and the audience, this is how we at 4M see the conflation process, and this is how we build at 4M the system that we have in our backend, and we call this an AI conflation engine. Now, what is this engine? We have created and we invested about a couple years in developing this technology that allows us to pull up any information that is available from the public that can be divided to 3 types of data sets, at least at a high level. The vector data, so all the GIS systems that are available to the public from the municipalities, from the railroad commission, from the cities, etc. The second aspect would be all the pixels, so the rasters, the images that were taken even 70, 60, or 80 years ago from satellites and airplanes long time ago, while stacking up all those images and applying computer vision algorithms, object detection, change detection algorithms to identify on-surface phenomena or on-surface features that can indicate on the presence of those utilities. Those can be trenches, road repairs, scars on the ground, manholes, poles, etc. The third aspect will be engineering documents, blueprints, GeoPDF files, any kind of plan sheets, as well as applying engineering logics. So identifying, for example, negative evidence. So if we have a cliff, does it make any sense that the fiber line would cross this cliff, for example, or not? So this will be maybe a negative evidence as opposed to positive evidence, as well as any kind of information that is available to the public, even from social media, for example. Now, the engine basically is taking all this information, synthesizing it into a one source fusion, merging the data to cross-check and verify the data, not only to correct the deviations and verify it, but also to add missing pipelines or cables that did not show up in the records nor in as-builts, etc. Some of them even can be abandoned pipelines or whatever. Eventually, all this data is integrated and merged into our system to produce eventually the 4M data at the end. Then this is the end result of what we're getting. Yet, combining this to what you just said before, this is still data that may be reliable or comes with a high degree of certainty or confidence. Yet, this needs to be combined with the professional engineer that needs to make decisions based on this data set. So in other words, I will describe that in a way that the forum data or this conflation process, the attempt or the goal of this conflation is to optimize the decision-making processes that the project manager, the project engineer, the utility coordinator, or whoever needs to make eventually before planning, designing, or definitely before putting a shovel into the ground. So I wanted to share with you all how we describe this process and how this can be aligned in the civil engineering and SU domain. I'm curious to hear your opinion, and then we'll try to shift gears. And I promise to have like a very quick demo of the product, and we want to open up the conversation for questions and answers. So maybe just a couple minutes talking about this, Jim or John.
I would say that if the amount of time available to get records is short and there isn't a lot of money available to get those records, why wouldn't you use a method that would give you the biggest bang for your buck right off the bat? And I think, you know, personally, I think the way forward for any designer of infrastructure project is collect as much utility information from all available sources as you can, analyze it, and use it effectively to eliminate cost and schedule delays in your project. And it just makes sense to me. I don't know of another option right now that is available other than 4M to, on a regular basis, collect all of that available public information knowledge that the utility owners are not going to collect and give to you if you ask them for your records. There is nowhere to get that information unless you send multiple people out yourselves, get on the phone, know how to use signal intercepts to pull data out of GIS databases or old file cabinets that have been digitized and available to the public. I just don't see it. So it seems to make sense to me that even if the data were only 70% complete and accurate to plus or minus 10 feet, it's a starting point that we don't yet have. And the more we feed that information of during construction back into that system, the better the analysis will be in the future.
That's an amazing way to describe that. Jim, just in interest of time, I promised to have like a very quick demo of to show the audience how we see this as 4M. And so I'm going to share my screen right now. Can you please confirm that you see this, because I'm sharing from a different laptop actually?
Yes, you can see it.
Okay, cool. So now let's take this whole context of conversation we had. I think we had a beautiful conversation, and focus that on the conflation and as well as how 4M deliverables or product really aligns with that. So really quickly, before we open up this forum or this webinar here for questions and answers, this is what basically 4M put together. So this is the very first interface that a user will see when a user logs into the product. And we can see here all the different points that represents projects that were delivered to our customers and users. Up to date, as I mentioned at the beginning, by the way, so 4M is creating basically the search engine of anything related to utilities above and underground. And as we're speaking, we're proactively mapping the entire United States. We are providing our data today in all 50 states, including even Canada. And to date, we have completely mapped 5 different states, which are Texas, California, Florida, Colorado, and Washington. Now, when we log into the system from the user standpoint, we can see all the different projects that my specific organization has. And what I'd like to do right now, we'll zoom into the area that I'm based right now, me and John Campbell. We're here in Austin, downtown, in Texas. And what I like to run like a very quick exercise. in terms of how a user can get access to the data. So creating a project, a user can upload his polygon very easily, or just draw the project by himself. And for the sake of this, let's say exercise, we'll just draw the project by ourselves. We can see all the different right-of-ways just popped up in blue. So let's just say we have a roadway expansion over here on the highway. So I just drew a rough area. We will call this one webinar. We will wait a couple seconds and we will get a utility density map. So I picked downtown Austin, so basically everything is almost red. But when I click on Reveal Insights, I get to unlock all the high-level analytics within the corridor of the project area. So what we can see here all the data that has been conflated already by the engine and the processes that we just discussed about a couple moments ago. So we can see here that within this area, we can find about 34-ish miles of communication lines, about 51 water lines. We can see how many underground lines versus overhead lines we can expect to encounter. When we click on utility owners, we can see the utility owners broken down by sectors. We can see 23 different communication owners, one water owner, obviously maybe City of Austin. And we can see the list of all the different owners. And as I'm sure everyone noticed, the lines of the map and the names of the owners are still blurred. The reason they're blurred is just because this is something we're providing as part of our platform or the free ecosystem. So basically, a user can get access, unlimited access to this feature throughout the entire pre-map states that we mapped. And when a user wants to get the conflated data to reveal the records themselves, the user needs to click on Get Data, where we provide two different options that applies for a different type of degree of confidence level. The first option we call the standard utility research, and the second option we call the advanced utility research. Each one of those data sets should be applied for a different type of application or a different type of use case. We do have a turnaround that could take a couple days for the standard research and maybe 1 or 2 weeks for the advanced. And we don't have the time to wait, obviously. So what I like to do right now is to zoom into a specific area that has been already delivered. Just a second, sorry. So we will go back again to downtown Austin. This particular case is Congress Avenue. So just outside of our office here, we can see how we initially started with the heat map. Everything was red, obviously. And right now we revealed the data. So what we can see here with this data set, oh, sorry about that again. When we go back to the analytics side, we can see all the different names of the utility owners. Plus, we can also slice and dice the data. For example, if we want to look only at Zayo lines, we can zoom in and see all the lines that are owned by Zayo. We can also see here, whenever we have the data available, the installation date, the size, and the material. So the standard utility research should typically be used during pursuits, preliminary planning phases, and eventually any place that you really need access to a record research or to the desktop level. So we get a very robust data set. In this particular case, it took us exactly 1 day to produce this data. So basically, going back to the conflation discussion, what the form data provides is the conflation process, or a way to expedite the desk study and the record research to get a robust data set very, very fast and seamless, or very easy. In the next phase, and this is where I will stop after this, so the advanced research will take the data that was initially provided with the standard research and conduct historical research, applying computer vision and change detection algorithms on images that were taken a very long time ago to identify trenches, road repairs, scars on the ground, even paved manholes, etc., to create this very robust observation. So we can expect with the advanced research to correct deviations, to add missing pipelines or cables that did not show up in the record research or in the standard research. We can see that in a CAD observation, and the data can be downloaded, as we can see here, the right top corner, and we can basically export any forms of GIS, AutoCAD, MicroStation files, as well as PDF. So we can take the data and run it throughout our own systems, whether it is ArcGIS, AutoCAD, microstation, or whatever we want to use. I will just indicate the last thing, that the advanced research should be utilized either pre-field investigation to help provide the context to the field investigators, to the SUE folks, to help optimize the SUE investigation or the field investigation processes, while providing the context of what and where to look for, thus hopefully saving time and money associated with field investigation, and or this data set can be utilized after field investigation as a QCA or a due diligence tool to ensure that we didn't miss anything, or to correct maybe the data that wasn't able to be verified while field investigation, to ensure we don't strike any lines when we put a shovel into the ground. So this is the very quick demo that I wanted to present to the audience here. I hope this makes sense. And with that, I'm happy to hear any additional thoughts maybe that John or Jim has. And we have 8 minutes, and we also promise to stop for questions and answers. So I'll kick it over to the air, and that's it from my side.
I would just add or say that graphic that we just saw of downtown Austin with utility data that came from sitting in an office somewhere and pushing some buttons and not going into the field because somebody in the past went in the field and collected data and put it somewhere, and we were able to gather that together. What a great start to a utility investigation that you would not have gotten from calling the utility owners and say, please give me your records of what you've got down there. It was much more complete than that. Now, was it as reliable, as accurate, as certain? We don't know that yet. We do know that it matched up with visible features that we were out there to look for. You know, it might be 80, 90, 97% accurate, 50% accurate. We're not sure yet. What we do know is that over time, that system will get better and better as projects happen and we confirm the data and now keep it for all time.
I'd add one thought to what Jim has to say. Of course, I agree with everything he says, and his observations typically reflect my own. But, you know, performing what I now have learned is conflation, my engineering analysis of the record information that I gathered. The one thing that I was always certain of is that I didn't have all the records available, that my data set was dramatically incomplete. And now what I can see is that if you can get this kind of information that has not only eliminated a huge amount of time at compiling it, but it also has given you the starting place, you know, the very first place I go through this iterative process of analyzing records is I go to the field and I start correlating what I see in actual presence with what those records indicate. So this would be an ideal place to start in that early part of the investigation. We better push it over to some questions.
Awesome. Thanks, everyone. Yeah, we have a couple of great questions from the audience here. And the first one is, with the onset of the massive amount of government funding being awarded to state entities for infrastructure improvement projects across the country and the labor shortage, how do you see technology playing a part in helping solve for these challenges?
Well, technology will be the only solution, I think, given that we don't have the trained technicians and specialists in the field. And we've seen that over the last I've seen it over the last 45 years of my career. The technology, the number of people I need to do what needs to be done in the field has consistently decreased over time because of technology. Whether it was no longer using colored pencils and making a paper map, and if you made a mistake, you had to start over, versus putting it onto a computer, you know, just simple things like that. But the efficiencies have been wrung out by technology, and this is another technology that will continue that trend, make things more efficient.
Great. And then being cognizant of time here, I'm going to do a little rapid fire. The next question is, where's the best use of this technology in the process? Can it be used in the beginning of the process instead of tracking down as-builts? How long would it take the technology to get this utility data?
Well, I have a couple.
No, go ahead, Jim.
Thoughts on that. You know, number one, the data is valuable from the beginning of the project. Now, where else can you use it? You can use it to keep the data current, because a project might take a long time to design and build. Things change, and trying to figure out what changed on my project when you're not there every day looking at who's building something new in that project area. That's a great tool. And it also helps for the quality assurance at the end to say, hey, did I have something from records or from visual observation that my geophysics didn't find? Maybe I need to go concentrate on that area a little bit more with a different type of geophysics or more diligence in that area. So I think you can use the data throughout the project life cycle and beyond, even for asset management in the future, but it really starts accruing its value at the very beginning of the project.
Jim, I would like to elaborate on that, because I really like your answer. And I will say that, why do we need utility data? What is the end result? We need utility data so we won't encounter, or we won't strike lines that can involve with accidents. Unfortunately, people get killed even from that, etc. So this is why we need the data. When do we need the data? I agree with you that we need to have a very high certainty, or a degree of certainty, early as possible on the life cycle of the project, from the very early planning phases, conceptual phases, even for pursuits. Yet, whether you're using I think that the question was referring to the form technology, whether you are using 4M or not, I believe that anyone needs to get a hold of reliable and to get a high degree of certainty of utility data set early as possible on the life cycle of the project. There will always be this threshold in terms of, do you want to send people to the field? How much time, money do you want to invest to get a hold of this data? However, I will transition my answer to the question that was asked. Yes, I think Jim answered that very good, that the forum data or any kind of reliable data set should be utilized early as possible on the life cycle. Yes, we also, as part of the technology that forum provides with the change detection AI algorithms, we are capable of maintaining the data up to date. So even if a line has been relocated or a new fiber line will show up in the area that was mapped already, the forum engine is able to capture that and to correct that and to keep the data set constantly up to date as needed.
Thanks, guys. And kind of related to that, the last question was, how is this going beyond quality level D data, this technology?
Well, it's not even quality. It's not even quality level D. It is just data until it is analyzed by a professional engineer who is going to put that quality level to the data set, to each individual data set.
And I was interrupting Jim to say the same thing. As a professional engineer that's in this business of analyzing those records, that's where my quality level D analysis begins, when I have a good comprehensive existing record set. But it does then take that intervention by the experience that's been, informed by years of practice in this, to then look at those records and be able to make those determinations, not only of a conflation type of approach to looking at and analyzing the data, but also to be able to qualify that data as quality level D within the ASCE standards.
Thank you. Awesome. Well, we're at the top of the hour here. It's 4:30. I want to be cognizant of everybody's time. I want to thank everybody for joining us here today. It was a great conversation. And as promised, early next week, everybody will get an on-demand version of this, so you can watch it as many times as you want. And please join us for part 2 of this masterclass series on November 8th, which will be on real-world applications of AI and how leading civil engineering firms integrate AI and big data into their utility mapping projects. And also, thank you for the panelists. You guys were great. I hope everybody was able to get an immense amount of value out of this today. And yes, thank you everybody for your time, and hope to see you on the next one.
Thank you very much.
Thank you.